So today we're going to be talking about making measurements and then also using what are called significant figures to determine how to make those measurements and then also how to do calculations by showing your precision. So the first thing we're going to talk about are measurements. Now there are two major types of measurements. You have qualitative measurements. Qualitative measurements give descriptions. Typically they're in non-numeric form. So this is saying the cup is red, or bubbles, were produced in this reaction. Those are all qualitative measurements. Then you have quantitative measurements. Quantitative measurements give results in a definite form. It just says that it happened or it didn't, or it's like a number. It's 7.3 grams of the carbon dioxide were formed. Um, these are sort of the two major things. We deal more in chemistry with quantitative measurements when we're talking about measuring instruments and things like that. We do qualitative measurements to really show you what happens with the reaction and things like that. So these are both equally important, but we're going to focus on the quantitative measurements today. So when you make measurements, you have to follow the rules of significant figures. Significant figures tends to be like a thorn in the side of some students. They just don't like them very much at all. But the reason why we do that is because measurement is where everything comes from. All these numbers come from something being measured. So the general rule for following measurement significant figures is you write down everything that you know, and then you make one estimation. What I mean by that is I know it's between 7 and 8 centimeters. I know it's between um, zero point 0.1 and zero point 0.2 centimeters, and then I make one estimation. The estimation always happens between graduations. Graduation is just a fancy word for the lines on the tools, but it's a technical term for it. If you think about something called a graduated cylinder, it just means that it's a cylinder that has lines on it. So graduations are just like those little lines on whatever tool that you're using. Um, the last digit is always the one that is estimated. So none of the other digits, they have to be known for sure that it has to be between this and this. That last digit is estimated, and you only get one digit to estimate it. Even if you think if it's a quarter of the way to, a quarter of the way into or between graduations, you can't write 25, 0.25. You have to write, make a decision, is it zero point 0.2 or is it zero point 0.3? So you get one digit of estimation. So let's figure out why we follow these rules. The reason why is to show the precision of your instrument. Whatever instrument you're using will dictate how many digits you get. If you have more digits, you are more precise, or you have more precision in your instrument. So we want to show that. We want to show off the precision of our instrument. You also can't show too much precision, right? So let's do some examples and we'll see how this sort of works. So here we have three different instruments in order to measure volume. We'll say that we have water in these things. So these are three different instruments to measure volume. The one on the left here, this is a beaker, right? We all know what a beaker looks like. It is not very many graduations on there. The center one here is our graduated cylinder, pretty tall, 50 milliliters total. And then the one on the right is probably a new piece of material. This is called a burette. Burettes are kind of weird because they're typically labeled upside down. This one's not, but they're very long and thin. So let's measure what these are going to be using our rules. So the rule says we measure everything that we know for sure. We write that down, and then we make one estimation. So let's go ahead and work on the beaker over here. Well, I know that the line here, the bottom of the meniscus, is between 20 and 30 milliliters. So I am going to write down the 2 representing the 20 here. Now, I need to make a determination of how far in between these graduations are. This is my estimation. This is where I'm figuring it out. I think it's about 8/10 of the way through. If we were to kind of split these up, eyeballing it, it's about 8/10 of the way through. So I'm going to write down an 8. So this is about 28 milliliters. And that's all we can do. So the 2-digit is what we know, the tens place is what we know, and then the ones place is our estimated digit. Let's go ahead and move on to the graduated cylinder. So the graduated cylinder, we know for sure that the line is between 28 and 29. So we write down 28. Now we're going to make an estimation of how far between these two things it is. To me, this looks about 2/10 of the way through. We're always going to be thinking about that tenths place. So this would be like 28.2. So I'm saying that I know it's between 28 and 29, so these are known. And then my estimation is that it's 2/10 of the way through. And once again, put that unit, that's a milliliter. Here we have the burette. So we know it's between 28 and 29. So we're going to write down that we have 28. Now, what do each one of these graduations represent? We have 28.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then we're to 19.0. See, each one of these little lines represents 0.1. So we know for sure that it's between 28.1, 0.2, 0.3, and 0.4. So we know it's between 28.3 and 28.4. So I write down that it's 28.3. Now I get to make an estimation. How far the way through is it? Well, I think it's, I don't know, 4/10, 3/10 of the way through, something like that. So I'm going to go ahead and write down 4. Now these are known. The 2, the 8, and the 3 are known. I know it's between 28 and 29. I know it's between 0.3 and 0.4. So this is my estimated digit. Notice in all of them, last digit written is an estimation. So you want to make sure that you are using these rules. Yes, it seems tedious, but this is the way that you need to do that. And notice, this is actually the same volume in all of these, but they're expressed differently because we have different instruments that are measuring them. So here we have a beaker, not very precise, not a lot of decimal places. Graduated cylinder, we're getting more precise, we're getting more decimal places. Burette, extremely precise. Burette's probably the most precise instrument we have to measure volume. So we get that. Now, if it was on a line, let's say it was right on this line, you would estimate that it's at 0.0. So your 0.0 would be estimated. And yes, you do need to show that because it shows the precision of the instrument. You can't just cut it off because it cuts it off in your calculator. You can't do that.